Okay guys, here's a basic rundown of an introduction to stoichiometry, and we'll continue to go a little more in depth as we go along, but I want to give you a basic overview of what. Right, stoichiometry is all about proportional relationships, and this is a revisit of a basic cookie recipe. I think this one's a little different than the one that I used as an example in class the other day. But basically, it's all about having that proportion of how many of this ingredient will produce how many of this end result, which is the cookies, right? So if we have a recipe that has 2 eggs and makes 5 dozen cookies, right? As we see here, we have 2 eggs and 5 dozen cookies. Then we can say, if I have 5 eggs, how many cookies can I make? Well, we know that for every 2 eggs, you can make 5 dozen cookies. That's the ratio of eggs to cookies. So we can say, if I have 5 eggs, and every 5 dozen cookies uses 2 eggs, then I would be able to make 12.5 dozen cookies. Now this is basic ratio math, and if you're struggling with the idea of proportional relationships, it's definitely something that you should come in for tutoring for, and you can even go to tutoring with your math instructor for this as well. So proportional relationships with chemistry, stoichiometry is how we define the mass relationships between substances in a chemical reaction. And it's based on something called the mole ratio. Now, the mole ratio is as simple as an understanding of the balanced equation. So when you look at the balanced equation, the coefficients in these balanced equations, so with the 2 in front of the magnesium, the 1 implied in front of the oxygen, and the 2 in front of this magnesium oxide, that is showing the mole ratio. That means for every 2 magnesium, we have 1 mole of oxygen and 2 moles of magnesium oxide. So this is what we refer to as the mole ratio, a very important phrase or term for you to understand. So that mole ratio comes from a balanced equation. Now remember, if your equation is not balanced, you don't have a clean mole ratio. All right, as we take a look at the coefficients. Now coefficients can stand for moles or particles, and that particles includes atoms or ions or molecules, and volumes of a gas. Now you will notice that the coefficients don't stand for one thing. What's missing here? We have moles, we have particles, we have volume. What we don't see is the mass. If we take a look, we can say 2H2 plus 8O2 will react to form 2 H2O molecules. Now this equation can be interpreted as 2 moles of hydrogen plus 1 mole of oxygen equals 2 moles of water. Or we could say that for every 2 molecules of hydrogen, there is 1 molecule of oxygen and will form 2 molecules of water. Or we could say that for 1 volume of hydrogen, that could be like liters of hydrogen, 1 volume of oxygen would create 2 volumes of water. Okay? What we cannot say is this equation cannot be interpreted as 2 grams of hydrogen and 1 gram of oxygen is 2 grams of water. That is not what our ratio, our mole ratio tells us. Okay? So, we can understand that the mole ratio is moles, tells us about liters of a gas, tells us about molecules, but does not tell us about grams. So there are several steps to stoichiometry, and these are steps that you've learned in the last 2 units. Those are the mole conversion unit as well as the chemical reactions unit. Number 1 says that you have to write a balanced equation. That might mean that you need to predict your products. You need to make sure that you balance the equation that you are writing, and that you identify your known and your unknown substances. Then you line up your conversion factors. For this, you'll need to know your mole ratio. That is how many moles of one substance compared to how many moles of another. Also, your molar mass. That's converting moles into grams, grams into moles. Molarity, which is moles to liters, liters to moles, and molar volume, which is moles to liters of a gas. The core step in all stoichiometry problems is this moles to moles conversion. This is the only part of this process that we have not done yet. And then, of course, the last step in any procedure is to check your answer. Okay, and on this diagram, you can see that you have the mole island. You should recognize this from our previous work that we've done, where you can convert from grams to moles using the molar mass, and you can convert from liters of gas to moles using the 22.4, and you can convert moles to atoms or ions using 6.02 times 10 to the 23rd, or you can convert moles of one substance to moles of a different substance using a balanced equation. And this is the basic map, the roadmap of stoichiometry. Everything on the bottom half of this page you've seen before. The only thing that we're changing is the balanced equation part for changing moles to moles of a different substance. This is another example of that mole map that I just showed you, and that you can go to liters of solution using molarity and liters of gas at STP using molar volume. Now, molarity is a little different. We're not going to go into that into a lot of detail until we cover solutions, which is 2 units from now. But here you see that you can convert moles to grams, moles to particles, moles to liters of gas, or moles to liters of solution. Now, in the next video, we're going to go over this mole map, which explains the process of stoichiometry step by step. So that will be a separate video. Thank you for listening.